Yeah, dear students, today we are discussing some problems on Doppler's effect. Uh, when the observer is at rest and the source is moving towards the observer. So this is the problem. So here, this is ambulance. This is the problems an ambulance moving towards an observer. Observer is at rest. If I represent VO, velocity of observer at rest, and this ambulance, it means that the ambulance is making a sound and then moving toward the observer. Now let us suppose its velocity of the source. Velocity of source, it is given that here velocity of source is 54 kilometer per hour. So here velocity of source is equal to 54 kilometer per hour. We have to convert into meter per second. So if I multiply this ones by 5 upon 18, after solving it comes out into 3 and 15 meter per second. This is the conversion methods, and the velocity of observer is at rest, and the original frequency of the horn making by the source is here the frequency is 450 hertz. 450 hertz. So since there is the distance between the source and observer is decreasing, so that there would be an increase in frequency of the sound. So since this is an apparent, not the real ones, so apparent frequency, if I represent by FA, so we have the formula FA is equal to apparent frequency. FA means the apparent frequency. It is observed by the observer. So we have velocity of the, here V is velocity of the air, velocity of sound in air. It is given 330 meter per second. 330 meter per second. In earlier topics we have discussed in the theory portion. Now our formula is V divided by V minus Vs into original frequency. This will be our apparent frequency. Since the factors of f0 is less than 1, because in the numerator it is V and the denominator V minus Vs, obviously V greater than V minus Vs. That's why apparent frequency will be increasing. If we put all these values, it will becomes 330 divided by 330 minus Vs has the value 15, multiply it with the original frequency of the sound, that is the horn. It is given 450 hertz. So if I calculate this one, 330 multiplied 450 divided by 330 minus 15 comes out 315. Now this value comes out after calculating 417.43 hertz. This much of frequency is listened by the observer. This is your observer, and so you have if I see here 450, this is the original frequency of the horn. Now this calculated value become 471.43 hertz, and our original frequency of the horn is 450 hertz. Now the apparent frequency of the sound is 471.43. So this is obviously more than that of this one. This is another questions in which our observer, this is our observer, this is a moving car which is blowing the horn, and it is moving. Suppose the car is moving away from the observer. This is the moving car whose velocity is vs, and this is the observer is at rest. So this moving car after blowing the sound moving away, and the observer at rest. The frequency as appeared to the observer is in a decreasing one. So let us suppose, so we have velocity of the sound which produced by the moving car. Suppose this is the original frequency of the sound, f4 500 hertz. Velocity of sound in air. Velocity of sound in air is 340 meter per second. 340 meter per second. And velocity of source. The source is moving away from the observer. That is 60 meter per second. Velocity of source is 60 meter per second. By the theoretical concept, whenever the separation between the observer and the source is increasing, the frequency appear to the observer is decreasing. So that's why this source is moving away. Our apparent frequency, Fa known as the apparent frequency, Fa will be our apparent frequency. It will decreasing. So Fa less than the original frequency. Our formula here for finding the apparent frequency to the observer is equal to V divided by V plus velocity of the source multiplied the original frequency of the sound. This is our formula. Now if I put all the values in these formulas, I will get velocity of sound in air is 340 meter per second divided by 340 and plus Vs. Vs is the velocity of the source. It has the value 60 plus 60 meter per second multiplied with the original frequency of the sound. That is 500 hertz. If you calculate this value, this comes out 340 multiplied 500 divided by 340 plus 60, it comes out 400. So so 85 multiplied 5, it comes out 5 into 5 is 25, 5 into 8 is 40, 40 plus 2 is 42, 425. So this comes out 425 hertz. 425 hertz. Our original frequency is 500 hertz, and apparent frequency to the observer is 425. The frequency is decreasing. So that's why whenever the relative distance between the observer and source is increasing, the frequency appear to the observers will decrease.